Summary measures. Skewed distribution. Now, what about if it is not symmetric? This is called a skewed distribution. If the two sides do not coincide, the distribution is said to be asymmetric. A distribution that is asymmetric with respect to the vertical axis is said to be skewed. We have two types: the negatively skewed or the skewed to the left distribution, and the positively skewed or skewed to the right distribution. Let's talk about these two in detail in the succeeding slides. Let's discuss first a positively skewed distribution. The longer upper tail indicates that there are observations in the data whose values are so much larger compared to the others. These few large observations will pull the value of the mean to the right of the distribution. Here's an example of a distribution of respondents' age that is skewed to the right. When we say skewed to the right, it has a longer upper tail or longer tail on the right of the distribution. If we try to compute for the summary measures median and mean, we will have 31.2 and 34.2 respectively. Let us see where these summary measures are in the distribution. The median can be plotted here with a value of 31.2. Then the mean is to the right of the median, which is 34.2. Looking at this, where are the observations or ages concentrated? Below the value of the mean or above the value of the mean? And the correct answer is below the value of the mean, because the height of the bars represents the magnitude or the number of observations. In this case, we have higher, and therefore more observations are concentrated to the left or below the mean value of 34.2. This tells us that the respondents are relatively young. There are some respondents that are old but very few. And these few high observations, which we consider as extreme values, pull the value of the mean and make the distribution skewed to the right. Take note, in a positively skewed distribution, the mean will be larger than the median. Let's have the negatively skewed distribution. When we have a negatively skewed distribution, the longer lower tail indicates that there are observations in the data whose values are so much smaller compared to the others. These few small observations will pull the value of the mean to the left of the distribution. Given the graph with the same variable of interest, age in years, let's see where the mean and the median are positioned. This is what a negatively skewed distribution looks like. And the mean of 64.8 years old is somewhere around here. The median of 69.2 years old can be plotted here. Again, let us think about the concentration of our respondents. Where do you think are the ages of the respondents concentrated on? Below the value of the mean or above the value of the mean? The correct answer is above the value of the mean of 64.8. Thus, we can say that the respondents are relatively old. There are young respondents, 20 to 29 years old, but very few. These values can be considered as extreme values that cause the distribution to be skewed. These values pull the value of the mean to the left. In a skewed to the left distribution, the mean will then be smaller than the median. Let us have a concrete example. I would like to present to you the graph of the frequency distribution of annual family income in Manila City. What is the shape of the data distribution? This is skewed to the right because you can see the tail here, where the frequencies are fewest, is located on the right. Wherever the tail is positioned, that is the direction of skewness. And we say the distribution is skewed to the right, or positively skewed. Take a look at our summary measures. We have here the mean, with a value of 422,655. Our median, with a value of 342,526. Our mean, with a value of 43,990. And our maximum, with a value of 3,792,778. Looking at their relative position in the distribution, we can see that they are positioned here. Notice that the mean is higher than the median. Usually, when we deal with annual family income, its distribution is skewed to the right. This means that the annual family income in Manila City are concentrated below the mean. Many families have lower income than the average value. There are also families with annual income that are very high, but they are very few, which are considered outliers. That makes the distribution skewed to the right. In actual application, statisticians and researchers, when looking at income distribution, are actually focusing more on the median rather than the mean. The same thing with the PSA. In PSA, they don't usually use the mean since outliers would skew its value. Instead, when looking at income distribution, they would use the median. Now, MS Excel uses the skew function, which for your reference, uses this formula involving just the sample size, the mean, and the standard deviation. There are other formulas available in the textbooks, but MS Excel uses this formula. More importantly now is how do we interpret the calculated numerical value of the coefficient of skewness. If the calculated value of the skewness is 0, the data distribution is symmetric. This means that the mean is equal to the median. If the skewness value is greater than 0, then it is positively skewed. The mean is greater than the median. If the computed value for skewness is less than 0, then it is negatively skewed, meaning the mean is less than the median. There is a precaution on this when computing for the values related to skewness. If the value or the computed value is close to 0, sometimes we say it is near symmetry. But we have to look at the histogram to confirm the results of the value of the skewness. Do not rely on the value of the skewness alone. It is best to also look at the frequency distribution or the frequency histogram to confirm the results. I hope everything is clear at this point, because that ends our discussion on the measures of skewness. That is all for this session.